First, let's take a look at what is Z-score for outlier detection. The Z-score, also called the standard score, helps us to understand if our data point is greater or smaller than the mean, which is the line in the normal distribution. As we can see, 95% of the data points lie between +2 -2 standard deviation, and the majority of 99.7% of the data points lie between +2 -3 standard deviation. We mainly use 99.7% for calculations. Thus, if the value is more than 3, that is, if the value is outside the majority, we call it an outlier. To calculate the Z-score, the formula is the data point minus the mean of all data points divided by the standard deviation of the dataset. Now let's look at an sample sum. These are the values: 1, 2, 2, 2, 3, 1, 1, 90, 2 and 2. Now the sum of all these are 106. And since we have 10 values, thus we divide it by 10 to get the mean, which is equal to 10.6. Now to find the standard deviation, we find the square of the difference between the data point and the mean, which is 10.6. This is the values for each of the point. Now after summing it and dividing it by 10, we get the variance, which is 751.25. And after finding its root, we get the standard deviation, which is 27.4089. And then we apply the Z-score formula to each if the values to find the outlier, which is data point minus the mean of all data points divided by the standard deviation of the dataset. And these are the final values of the Z-score now, as we can see that the point 90 is an outlier as its value is greater than 3. Now finally, let's take a look at our Z-score code. We start by importing the libraries, Pandas for creating the data frame and NumPy for calculations. The data points for this example are 10, 12, 13, 12, 15, 17, 18, 100, 16, 15, 14, 13, 9. Then we covered this into a data frame for ease of comparison in the later parts. Then we find the mean and standard deviation using the NumPy library. Then we will find the Z-score for each of the data values using the formula, that is data point minus the mean of all data points divided by the standard deviation. We have defined the threshold to be 3 now. To detect the outliers, we will be using lambda function to check if the absolute value of the Z-score is greater than or less than the threshold for each of the data point and print yes if it's an outlier, else no. First, solve it. Now, as we can see in this graph, all the values are in the range 0 to 20 except for 100. These are the values we'll find if we do the sum manually. As we can see that data value 100 has a Z-score of 3.44, which is greater than the threshold, hence it's an outlier. Now back to the code. Looks like the value we found are same as the value we computed. Hence only for data point 100 it has a yes printed. And that's it. Thanks for watching.